কিছুই তো শোনা যাচ্ছে না।
স্যার কিছু বলতেছে না।
স্যার মাইক মিউট করো।
Okay, boys and girls, I'm going to start another class for science for class 8, and in the chapter number 11 on the basis of light. My today's topic is critical angle and total internal reflection. My today's topic is critical angle and total internal reflection. Boys and girls, at first I want to know what is called critical angle. Critical angle. At first I want to know what is called critical angle. Let's see critical angle. Suppose this is separation medium x, y. This separation medium can separate two medium here. This surface can separate two medium here. One is denser medium and another is rarer medium. You know that the bottom one is the denser medium. Denser medium. I know that the above one is the rarer medium. Rarer medium. Okay, so above one is the rarer medium. Now you see this. This is a normal line, or this is a vertical line. Okay, so this is N, O, N prime. Is normal line or vertical line. You see here, when ray of light incident obliquely from denser medium to rarer medium. I repeat again, boys and girls. When ray of light incident obliquely from denser medium to rarer medium. Then what is happening here? You see this. The refracted light goes away from the normal light. You see here, the refracted light goes away from the normal light. Suppose here A, O, B. So here A is the incident ray and here OB is the refracted ray. Now, if I increase the angle of incidence here, then see that if I increase the angle of incidence in this particular direction, suppose I'm going to increase the angle of incidence in this particular direction, then what is happening here? You'll see that the refracted light goes in the forward downward direction in this particular path. Goes in the downward direction in this particular path. Okay. So, for the case of a particular angle of incidence, I repeat, for the case of a particular angle of incidence, you see this. Here, a particular angle of incidence, suppose CO. For this particular angle of incidence I, you can see that refracted ray, it goes along the plane of separation, OD. Refracted ray OD, it goes along the plane of separation. Since this refracted light OD goes along the plane of separation, I repeat, since this refracted light OD goes along the plane of separation, for this case, I can say that angle of refraction R, this R will be equal to 90 degree. Angle of refraction R, this R will be equal to 90 degree. Then, the angle of incidence I got here in the denser medium, this angle of incidence is known as critical angle. I repeat, the angle of incidence I got here in the denser medium, this angle of incidence is called critical angle. So, I can say that. What is called critical angle? When ray of light incident obliquely from denser medium to rarer medium. Rarer medium. Obliquely from denser medium to rarer medium. At a fixed angle of incidence. At a fixed angle of incidence. At a fixed angle of incidence, so that at a fixed angle of incidence, so that angle of refraction is 90 degree, or refracted light goes along to the plane of separation, comma. That particular angle of incidence is called particular angle of incidence is called critical angle. So I read it again, boys and girls. Here, critical angle. When ray of light incident obliquely from denser medium to rarer medium at a fixed angle of incidence, so that angle of refraction becomes 90 degree, or refracted ray goes along the plane of separation, That particular angle of incidence is called critical angle. So in this case, that particular or that fixed angle of incidence is called critical angle. You see here, for angle of incidence CON prime, for angle of incidence CON prime, or for the case of incident ray CO, you see this refracted light. In this particular case, refracted light OD, you see here, goes along the plane of separation. Or here, angle of refraction here NOD, makes an angle 90 degree. What? Angle of refraction here NOD makes an angle 90 degree. So this particular angle of refraction is known as critical angle. I repeat, sorry, this particular angle of incidence is known as incident angle. CON prime is called critical angle. So I can say that when ray of light incident obliquely from denser medium. So CO, incident obliquely or inclined from denser medium at a fixed angle of incidence. What? CON prime. For this fixed angle of incidence, you see that angle of refraction. What? OD. So here OD is the angle of refraction.
Sir,
This OD becomes
goes along the part of plane of separation. এরপরে স্যার কি লেখা স্যার
goes
দেখতে
along
পাচ্ছি
the plane of separation, then comma, goes along the plane of separation, then comma. Then that particular angle of incidence is called critical angle. That particular.
So what do you mean by R? R.
In which place you see R?
So R equals to 90 degree
Exactly.
angle.
R equal to angle of refraction. So here R equal to angle of refraction. So here you see that this is angle of refraction, this is angle of incidence. So you can see here R equal to angle of refraction. Angle of refraction is nothing but 90 degree, and here I equal to angle of incidence is nothing but critical angle theta c. Critical angle. You know that here this symbol, just like 0, this symbol is known as theta, and always theta indicates an angle. Okay, so this is an angle theta, and this theta indicates that critical angle. Okay, so C stands for critical. So here theta C stands here critical angle. So I can say that this theta C or critical angle. I repeat, this theta C or critical angle. Okay, so this critical angle indicates you that this ray of light, just for this particular angle of incidence, this ray of light goes along the plane of separation. So along OD or along OY. Okay, so for this particular angle of incidence in the denser medium, you know that this angle of incidence is known as critical angle. Now, boys and girls, anyone have any confusion about critical angle?
Sir, in critical angle, এটা তো খালি ডেন্সের থেকে রেয়ারে হয় না?
Exactly. So critical angle is possible only for the case of movement of light from denser medium to rarer medium. Okay. So any other question, boys and girls? Anyone? Any other question?
Yes, sir.
I have
Sir, যদি আমরা আপনার যে ইনসিডেন্ট রেটাকে আরেকটু উপরে নিয়ে যাই, যেমন সি অ্যাঙ্গেল থেকে আরেকটু উপরে নেই, তাহলে কি হবে?
Okay. Let's see. And another question, boys and girls? Another question? Any more question?
Yes, sir. I have a practical that question. I want to ask you: is it applicable or not? Sir. Okay. So from a denser part of Earth, suppose from a water, if we set a big amount of light from the part of Earth where is light, then if that then in such a critical angle, then can we take this refraction of light to the other part of the world where is no light? That means there will be always day and night. Sir, এমন কিছু হতে পারে স্যার, যদি আমরা একটা big amount of light একটা জায়গায় critical angle রাখতে পারি একটা আর্থের ডেন্সার পার্টে, এরপরে কি স্যার এমন ভাবে যদি যায় স্যার, তাহলে তো এটা সমান ভাবে গেলে যদি অ্যাঙ্গেল অফ সেপারেশনের সাথে যদি যায়, তাহলে তো স্যার ওই একটা পাশে যাইতে পারবে।
ওকে, আপনার পাশে প্রবলেম হচ্ছে কি জানো, ঠিক সমানভাবে যেতে পারবে না, বুঝতে পারছো? তার মেইন কারণ হচ্ছে কি, বাতাসে যখন সে পাস করবে, ঠিক আছে, তো বাতাসে বিভিন্ন লেয়ারের ডেনসিটি ডিফারেন্ট। দেখা যাচ্ছে নিচে বাতাসের ডেনসিটি হচ্ছে বেশি, উপর বাতাসের ডেনসিটি হচ্ছে কম। তা যখন সে পাস করবে তখন সে বাতাসের মধ্যে বেঁকে যাবে, বুঝতে পারছো? তো এটা হচ্ছে কি ক্রিটিক্যাল অ্যাঙ্গেল কনসেপ্ট শুধুমাত্র এখানেই অ্যাপ্লিকেবল, just this is the last part of refraction of light. Okay, this is the last state for refraction of light. Okay, so if you increase the angle of incidence more than critical angle, if you increase the angle of incidence more than critical angle, then here no refraction of light takes place. So on the basis of this phenomena, okay, some optical incident takes place here in this earth. Suppose for the case of optical fiber, you can build optical fiber, you can explain mirage. So this kind of thing explained only by using after critical angle concept, that is called total internal reflection. So critical angle only gives you the idea. So what in between which angle of incidence you'll get angle of refraction only. Suppose for example here NOC, this is the maximum angle. Okay, so in between this maximum angle we just want to gauge the refraction of light. Okay, but when ray of light is incident from the denser medium to rarer medium more than this particular angle, then what is happening here? Then see this, for that particular case ray of light doesn't give any refraction of light. In that particular case ray of light only show reflection of light. So let's see, if incident angle is more than CON prime, then what will be happening here? Suppose for example, suppose here another incident ray is denoted by 3 arrow mark. So it is EON prime. It is what? EON prime. This is the another incident ray. So for this incident ray, incident at point O. I repeat, when this incident ray incident at point O, then what is happening here? When this incident ray incident at point O, then you can say that EO incident at point O, EO incident at point O. Then see this, after diffraction, after incident at point O, ray of light just comes this particular direction. This particular direction along wave path. So here no refraction of light takes place. You see that light always passes from any medium to another medium if that two particular medium are the transparent medium. So here you see the denser medium is the transparent medium.
বুঝি নাই স্যার।
আচ্ছা আবার বলে দেখো, here denser medium is the transparent medium. So here rarer medium is the another transparent medium. Okay, so you see when incident ray, suppose CON prime is the angle of incidence, CON prime is the angle of incidence. Okay, so for this case ray of light goes through OD direction. Now if incident ray incident at this denser to rarer medium more than critical angle, then what is happening here? You see here EO incident at point O and angle of incidence EON prime is greater than critical angle. So when angle of incidence is more than critical angle, then what is happening here? You see that after refraction, no ray of light goes to the second medium, but you see total ray of light that is returned back to the first medium along OF path. Total ray of light returns back to the first medium along OF path. Since total ray of light returns back to the first medium, I repeat, since total ray of light returns back to the first medium. Okay, that's why you can say that here ray of light returns back to O to F direction. This is called reflection of light, but you see this reflection of light takes place only for the presence of mirror, but here you get reflection of light without any mirror. That's why this kind of reflection is known as total internal reflection. Why internal? Because you see that total ray of light just striking at point O, and after striking at point O returns back to the water medium. So when it returns back to the water medium, I repeat boys and girls, when total ray of light returns back to the water medium, that's why what is happening there? You see the water medium become glossy. Okay, after this phenomenon water medium becomes glossy and just look like diamond. You see, it seems to you that water just glow light. Okay, so this phenomenon of light is known as total internal reflection. Now in next step I'm going to write down the definition of total internal reflection.
স্যার
Yes,
মানুষ যে বলে পানি ঝিকঝিক করে, এটা কি মানে এটা রেজাল্ট ক্রিটিক্যাল অ্যাঙ্গেলের?
না, পানি চিকচিক করে ক্রিটিক্যাল অ্যাঙ্গেল রেজাল্ট না। ঠিক পানি চিকচিক করে কখন জানো? যখন দেখা যায় যেটা পরন্ত বিকেলে লাইটটা একটু কোনাকুনি পড়ে পানির উপর, তখন সে লাইট যখন রিফ্লেকশন হয়ে চোখে আসে তখন পানি চিকচিক করে। বর্তমান যে কেসটা বলতেছিলাম আমি টোটাল ইন্টারনাল রিফ্লেকশন, এটি অ্যাপ্লিকেশনটা কোথায়? দিস ইজ ইউজড ওকে ইনসাইড হচ্ছে সাপোজ inside optical fiber. Suppose for example you see inside optical fiber you see that total ray of light ki hocche tar ekhane just become reflected from the wall and returns back to the first medium in optical fiber. Okay, and by repeating this phenomena again and again you see that ray of light pass through the optical fiber medium. I repeat, by repeating this thing again and again you see that ray of light pass through the optical fiber medium. Okay, again, so this phenomena is working in the case of optical fiber. Okay, in the case of optical fiber or water pool. If you go to the water pool at night, you see that in water pool, you see the bottom surface of the water pool, some light is added in such an angle that when those lights turn on, then total water just look like diamond. Okay, so at night the total water does look like diamond because of total internal reflection. So it seems to you that that water glow light. Now I'm going to give you the definition of total internal reflection. Now let's see what is called total internal reflection. Yes. Yes.
অ্যাঙ্গেল বের করে কোন মেথড আছে?
Measure বলতে কি যে it just give you idea. In between this critical angle, ray of light just give you reflection of light. But beyond that particular angle, ray of light doesn't show refraction of light. Okay. Suppose CON prime. Its main uses here in between this CON prime. In between this CON prime, only ray of light can show refraction of light. But beyond this level, ray of light cannot show refraction of light. I repeat, but beyond this level, ray of light cannot show refraction of light. Okay. So it just gives you idea in which region, in which area of angle this ray of light just bend, just show refraction of light. Now, I'm going to give you the definition of total internal reflection. So, total internal reflection. Now, let's see what is called total internal reflection. Again, this is a very big definition. When ray of light incident obliquely from denser medium to rarer medium. From denser medium to rarer medium at a fixed angle of incidence. At a fixed angle of incidence. At a fixed angle of incidence, which one is more than critical angle. Which one is more than critical angle? Then total ray of light returns back to the first medium. Then total ray of light returns back to the first medium, comma. This phenomena of light, this phenomena of light is called critical angle.
Sir, total internal
Sir,
reflection,
total-
no?
Total
Yes,
internal
it is.
reflection.
Total internal reflection. Thank you very much. It is total internal reflection. It's total internal reflection. Okay, I repeat it again, boys and girls. When ray of light incident obliquely from denser medium to rarer medium at a fixed angle of incidence, which one is more than critical angle. Then total ray of light returns back to the first medium. This phenomenon of light is called total internal reflection. You see here EO incident at an angle, which one is more than critical angle, CON prime or theta C. So because of this, you see that after refraction, here OF returns back to the first medium. Since here OF returns back to the first medium, that's why this is called total internal reflection. Now my next topic is, what are the conditions for total internal reflection? So what are the conditions for this total internal reflection? Let's see. So condition for total internal reflection. You see, boys and girls, there are two conditions for the case of total internal reflection. The first condition is ray of light passes from denser medium to rarer medium. If ray of light doesn't pass from denser to rarer medium, then no total internal reflection will be observed. So I can say that the first condition is ray of light passes from denser medium to rarer medium. Ray of light passes from denser medium to rarer medium. Now my second point is here. That is angle of incidence. Angle of incidence is more than critical angle. So in this case, you can say that angle of incidence is more than critical angle. So these are the two conditions for the case of total internal reflection. I repeat, boys and girls, these are the two conditions for the case of total internal reflection.